Hey, geometry kiddos. Mr. Cruze here with a geometry video for you. Obviously, I'm not there in person, but hey, learning can still continue. You don't need me physically to be there to teach you. Obviously, this video is going to have everything you need to fill out the notes. If you feel like I'm going too quickly, or if I say something you're not sure about, obviously pause the video and catch up, or rewind the video, rewatch it. You can watch this as many times as you want. That's the benefit of video. But I'm going to go through the notes relatively quickly. So again, just kind of pause as you need to. So we talked yesterday about two polygons being similar if their corresponding angles are all congruent and their corresponding sides are all in the same ratio. They're proportional. However, with triangles, we don't want to do that all the time. So we're going to have a shortcut. Now you might remember from triangle congruence, two of our shortcuts were angle side angle and angle angle side, right? Those were two of our shortcuts. We're actually going to use them in a slightly different form as a way to prove triangles similar. And this time, you actually don't need a side at all. This is what is known as the Angle Angle Similarity Postulate, or AA. And really, I probably made a typo here. This should really be AA Similarity. You might want to make sure you write the similarity, and there's a reason for that we'll talk about later. But anyway, Angle Angle Similarity. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles themselves are similar. So all you need are one pair of angles that are congruent and a second pair of angles that are congruent. So you've got one pair there, angle A and angle D. You've got another pair here, angle B and angle E. And because two of the pairs of angles are congruent between those two triangles, then the triangles themselves are similar. Triangle ABC is similar to triangle DEF. That's all you need to show. You can actually just show that two pairs of angles are congruent between your two triangles, and boom, they are similar. You don't need a side or anything, just the angles themselves. By the way, this is a postulate. I don't have to prove it to you. You will notice we don't need all three angles, and the reason there is simple. If two of the angles are congruent in both of these triangles, then obviously the third angles have to be congruent as well. Feel free to try and prove that on your own if you'd like. Okay? So basically what we're going to be looking for is our two pairs of angles congruent. So our instructions are going to be very easy. Determine whether the triangles are similar. If they are, write a similarity statement and then explain our reasoning, which our reasoning at this point is going to be simple. All right? So I look at these two triangles, and immediately I'm drawn to the fact that they have a pair of right angles. So automatically, we've got A. We've got one pair of angles that are the same. But I look at these other two, and I go, ooh, 61 and 29, those are not the same. So my thought is just give up, right? No. What about these third angles? Could we find the third angles in those triangles? We sure can, and really it doesn't matter which triangle you pick. I'm going to pick the bigger triangle. Why not? Let's find angle F. So we do what we normally do. We take 61 plus 90, and we get, what, 151? And then we subtract that from 180 because all three angles in any triangle add up to 180. And you will notice that this third angle, angle F, is now 29 degrees. Now do we have a second pair of angles that are the same? And it turns out we do. So we actually have both angle, and thus the triangles are going to be similar. So the answer here is yes. We're going to name the triangles. Again, order doesn't matter as long as you are consistent. So I'm going to go HGF is similar to, and we went HGF. So we started at the 61 degree angle. By the way, that would be angle K if you happen to find angle K there. We went to G, which was the right angle, so we have to go to angle L, and then followed by angle J. And our reason is what we said over here, angle-angle similarity. That is why they are similar. That's the idea. That's it. The two triangles are similar by angle-angle. Let's try number 2. This one's a little tricky. We've actually got a triangle inside a triangle. I don't know if you can see this. We've got triangle GLH, and we've got triangle GKJ. All right, we've got two triangles there. Feel free to draw them separately if you have to. If you're that kind of person, you want to draw them separately. Draw the bigger one, G, K, J, that's fine. We know this angle's 27. So we've already got one pair of angles that are the same. The question is, do we have a second pair? Like, we've got angle. Do we have a second pair the same? If you notice carefully, don't they both have angle G in them? right? I mean, angle KGJ is the same as angle LGH, right? It's the same angle. So it turns out they do have a second angle congruent. So we do have angle angle similarity. So the answer is yes. Name one of the triangles. Again, doesn't matter the order as long as you are consistent. So I went triangle GLH, and that's congruent to triangle GKJ. Okay, very nice. All right, in example 3 here, you will notice we already have two pairs of angles that are the same, so automatically the triangles are congruent. So we're going to write a similarity statement for the triangles. Easily done. Name the triangle. So I went with ABC, and that is similar to triangle DEF. Again, make sure the order doesn't matter in the first one, but you have to match it in the second. Let's find the value of the variable. So basically do what we did yesterday. So we are going to do 5 over 3 equals 15 over y. Cross multiply, we get 5y equals 45, which means y is 9. And then we're going to find the scale factor of the triangle on top to the triangle on bottom. So we're going to find the scale factor. Remember, all you do to find scale factor, and this is the part that I think a lot of people struggle with every year, is you take one side from one triangle, obviously the triangle on top first, so you can take either the 5 or the 15. I'm going to take the 5 because it's a smaller number, and you put it over its matching counterpart in the other triangle. So AB matches up with DE, which is 3. So the scale factor is 5/3. You could also do 15 over what we just found, 9, and you would see that that would reduce to 5/3. But by picking 5 and 3, the smaller of the two, we save ourselves a little bit of reducing. That's it. That's pretty much the idea here. Let's try this one. Same instructions. So write a similarity statement for the triangles. You will notice they only have one pair of angles that are marked as the same. But can you tell me where the second angle is? I hope you mentioned the vertical angles here in the middle. Yep, those make a sudden and inevitable return. So yes, these triangles are similar. I don't even need to say yes. We're just writing a similarity statement. So name one of them. Just be careful. Make sure you go the right order. I'm going to go ABD. And if I go ABD, I'm going unmarked, 2 marks, 1 mark. So I would go EBC. Okay. As far as solving for Z here, easily done. Z matches up with 6. And then 6 matches up with 12. And again, make sure I did Z over 6, so I have to do 6 over 12. And by the way, it's Z over this 6 equals this 6 over this 12. Okay. Cross multiply here. We get 12Z equals 36, which means Z is, you said it, 3. Nice job. What's the scale factor? Again, did they give us instructions? Yes. On the left, the triangle on the right. So we're going to do on the left first, so pick one of the sides there. I would probably pick the 12. And let's match it with its counterpart in the other triangle, which is 6. And that reduces to 2 over 1. That is my scale factor. All right. Last but not least, here's the last example. A stick 2 meters long, that's right here, is placed vertically at point A. The top of the stick is in line with the top of a tree from a point which is 3 meters from the stick. So this down here is actually 3. From this point to A is 3. And 30 meters from the tree. How tall is the tree? I'm trying to find the height of the tree. I'm going to call it H. Well, you'll notice we've got 2 similar triangles here. We've got this small triangle, which has 3 at the bottom and 2 here. And then we've got the big honkin' triangle, which has the tree. We don't know its height, but we do know the base is 30. By the way, why are these similar? We're going to make an assumption here and assume that the stick is placed vertically and that the tree grew vertically, so they have right angles in common. And they share this corner angle here. So they are similar by angle angle, so we can set up our ratios. A couple ways you could do this. I would do H over 2 equals 30 over 3. And then we're going to cross multiply. We get 3H equals 60. So the height of the tree is 20, and they used meters, so we're going to call it 20 meters. That's it. The big idea I want you to walk away from today is knowing that angle-angle similarity is a thing. You only need 2 pairs of angles that are congruent between your 2 triangles, and boom, they are similar. That's it for me, guys. Obviously, fill out the notes. Make sure you're ready to go. The homework is yours to try. Obviously, you may check your answers in the binder. Be good for my sub. and have a wonderful Thursday.